Hi, my name is Kai and I am part of Troop 56928. Not only am I a Girl Scout, I'm also from an FTC robotics team, Acmatics, Team 16177. This is a video from a series of videos for the Girl Scout robotics badges, ranging from daisies to ambassadors. I hope you learn about robotics and enjoy.
Sense, think, act process. Sense receives information about the world around it. Think and uses the program necessary with the information. And act uses the program to move or affect the world around it. Robots are also made of 5 parts. Sensors, they receive information from the environment and send to the robot. Controllers, helps the robot think and process the information from the sensors and decide how to act. Housing is the body of the robot. Actuators, the power system of the robot. Effectors, the parts of the robot that moves the robot around. An actuator takes energy and uses it to power a robot's movement. An algorithm is a set of step-by-step instructions to carry out a task. Artificial intelligence, or AI, is a type of computer program that acts as if it can think like a human. Autonomous robots work some or all of the time without human control. Binary is a way of presenting information using only 2 symbols. In math, a binary system consists of the numbers 0 and 1. A bug is a problem in a computer program. To get rid of the problem, you debug the program. A circuit is a path for electricity to travel along. Most circuits are designed as loops with a switch that can open and close the circuit. Like a drawbridge, a circuit must be closed for electricity to flow. Coding means writing a computer program, which is also known as code. A command is one step in a computer program. A computer program is a set of instructions that tells the machine what to do. A conditional statement in a computer program tells the computer to make a choice between 2 or more actions. It is usually written in the form if then else. If a certain condition is true, then the computer will take one action. If it is false, the computer will take the other action. For a loop, the statement might be repeat until a condition is true. Conductive materials are substances that carry electricity easily, like metal. Data is information that a computer can understand. Documentation means keeping a record as you create your design from idea to compilation. An effector is part of a robot that can move around like arms or legs. A function is a mini program within another program. It's a series of commands that is given a name. When you call the function's name in a program, those commands are carried out at that point. Housing refers to a robot's body. Insulating materials don't carry electricity easily. They are used to cover conductive materials and keep electricity from leaving the circuit. A loop is a computer programming shortcut that tells the computer to go back and repeat a series of commands. A programmable body is a way of controlling how a robot moves by changing its physical design. Pseudocode means writing out a computer program in everyday language. It is used as a quick way to plan out a computer program without translating it into a programming language. A robot is a machine that can perform 3 kinds of tasks: sense, think, and act. A roboticist is a scientist who works on robots and related technology. Robotics is the branch of technology that deals with designing, building, and using robots. A sensor is an electronic component that transmits information to the robot about its environment. The uncanny valley is the point at which an artificial life form that looks almost real appears more threatening than friendly. A circuit is a path for electricity to flow. It's made of conductive material, a substance that carries electricity easily. It is surrounded by insulating material that doesn't carry electricity. A sensor is basically an on and off switch for an electrical circuit. The right conditions cause electricity to flow in the circuit, and send a signal to a computer or other kind of electronic controller. A computer program then tells the computer what to do. For electricity to flow in a circuit, there needs to be a place for it to go, usually a circuit designed in a loop, so that the electricity flows around and around. A battery or other power source has a positive end where the electricity comes out and a negative end where it goes back in. For electricity to flow, the circuit must be connected to both sides of the battery. For electricity to flow, a circuit must be closed. If a circuit is connected to ends of a battery, but there is an opening anywhere in the circuit, nothing happens. This is called an open circuit. A switch or sensor controls the flow of electricity by opening and closing the circuit. It's like a drawbridge over the gap in the circuit. When the drawbridge is down, electricity can travel around the circuit. When it is up or open, no electricity flows. Some sensors can let higher or lower amounts of electricity flow, like the dimmer switch on a light. These kinds of sensors give variable readings, such as high or low air pressure. Electrical components also have positive and negative ends. Some components, like LEDs, will only work if the positive and negative ends are connected in the same direction as the battery, that is, positive to positive and negative to negative. On an LED, the longer wire, or lead, is positive. There is also a flat spot on the edge of the light LED bulb. The wire on that side is negative. Imagine a robot. How does it use the sense, think, act process? How do the 5 parts of the robot work together? On a robot, sensors are used to give the robot the information it needs. Sensors can range from acting like a switch to telling a robot which direction it is facing. Learn how robots use sensors by making a pressure sensor.
So this is how you make a pressure sensor, and what you're going to need is a battery like this one, a diode like this, and then a paper clip. And you're also going to need a piece of paper, and then 4 aluminum foil strips of aluminum foil. One is going to be longer, one's going to be about medium sized, and 2 are going to be smaller. So you're going to want to start out with laying them out just to make sure that they'll be okay distance wise from each other, and that you cut them okay. So the 2 short ones are going to be on top, the medium size is going to be on the side, and then the larger one is going to be on the bottom. So once we got that okay, we're going to make a fold to the first short one. So see the short one? I'm going to make a fold to that. You'll see why in a little bit. But we're going to start with taping the first short one down. We're going to only want to tape it on the edges, and just enough to hold it down, but not interfere with the connection that the foil is going to have with each other. So we're going to take the next short one, making sure that it's not touching. And we're going to also do the same. I'm going to just put it right on the edges. Now we're going to take the medium-sized one, and we're going to put it on the side. Make sure it's not touching, and that it's right on the edges too. So right now it should kind of look like this, where now the edges are touching each other. Now we're going to take the final strip, the long one, and we're going to put it towards the bottom, but closer, and making sure, again, it's not touching anything. Just going to put it in small pieces down, and we're going to see just like that. Okay, so we're going to start out with, now we're going to grab our diode. This is what it looks like. And there's one longer prong and one shorter prong. The longer prong is going to go to the right, and the shorter prong is going to go to the left. And it's going to be right in between these two. So we're going to put tape on it, and it's okay if the tape covers it as long as it's touching the aluminum. And now we're going to put the battery down with the positive side is facing up, and we're going to put it on this one. And right now the diode should look something like this. So we're going to put tape, or we're going to just put it positive side facing up, and we're going to have just tape it down slightly, but making sure it doesn't interfere with the connection. So I only taped it down like a little bit. And now we're going to take this foil, the bottom foil, in that fold that we made earlier. We're going to fold it to the battery. It might look a little bit messy, like mine, but if it looks messy, it's okay. So just making sure the aluminum is touching the battery, and then once that, you can secure it with the paper clip. So it should look something like this. And then to finish off the circuit, you're just going to take the side piece and you're going to fold it to connect to the other aluminum pieces. And it should light up. And that's how you create a pressure circuit.
Robots are programmed to react to its sensors. A light sensor can make a robot to follow a black line, and a touch sensor can make a robot turn when it hits an object. Now you can see how sensors send information to the robot by using the pressure sensor you created. Attach the sensor to a box and move the box around to see when this sensor lights up.
So now I attached my pressure sensor, looks a little bit messy, but that's okay, to my box robot. And we're going to show how a pressure sensor works using a box robot. So let's just say my robot is driving, and my hand will be a wall, and it hits my hand. That pressure sensor will collapse, and the light will light up. And then that'll signify to the robot that it can stop, it can go back, and then it can turn right, or whatever the program says to do. So that's what my program would say, is to have it stop when it hits a wall, go back, and then turn to the right, as if it's in like a maze.
Robots use programs to complete different tasks. Programs are written as step-by-step instructions for robots so they know how to complete different tasks. Test this out by telling someone how to complete a task using an algorithm or a set of instructions to complete a task. Use if-then conditional statements, loops, and functions to simplify your program. After you are done, you can write a program for an actual robot. Hold on to your robot. You'll be using it to complete Cadet Batch 2. which will be covered in another video.
Thank you all for watching, and give me feedback with the link below.